Good morning, you're welcome to MAMU with Jarvis, and this is our grade 10 experience. And our textbook of reference is the Essential Mathematics for SS1. Very nice book, very good book, especially if you want to have an exciting experience in mathematics. Our area of focus today will be geometry, study of shapes, two-dimensional, three-dimensional. And in the manner we are going to be looking at geometry will take into consideration geometry, trigonometry. And I think in one of my classes I had said that when we talk about formal geometry, we're concerned with what is called formal geometry and mensuration. So the area we're looking at now is an area that is called formal geometry, using deductive reasoning to prove values for angles and the likes. Now, we had started solving before now, and I actually sent some questions to us prior to now. So we'll pick it up from where we stopped, and using our Essential Mathematics textbook, is one textbook you can buy on your own and keep, because this is usually my official text for these my online classes. I'm using Essential Mathematics for my online classes. You can have it as an additional reference materials to help your experience in mathematics. All right, so we'll be looking at exercise 15.1, and our focus will be to try to solve question 4 and 5, and after that we'll go into the study of triangles as it pertains to what is called formal geometry. So let's get down to business. So question 4, I'll try to draw the diagram on the board. Exercise 15 points. Question 4. All right, so let's start off with that. So let's look at that. Now the question says in the diagram, QR is parallel to what? TP. And angle WPT is 88 degrees. Find X. So let's draw the diagram and have a meta picture of what we are required to do. So this is the diagram we have. So this is parallel to this. This is R, this is Q. This is T and this is P. So this is the figure we have. The whole of this angle here is 3x. This angle is x. The whole of this angle here is 88. Now we are told that QR is parallel to what? TP. And the angle WPT is this angle, 88 degrees. Now you're told to find the value of x. This happens to be a formal y question. We're told to find the value of x. Now, what you're going to do in solving this problem is to try to construct another parallel line. Let's call it AB, such that AB becomes parallel to TP and is also parallel to this. Now, once you've done that, what you will notice from your knowledge of geometry will be this: that this angle here will also become x by virtue of what? Alternate angles. This angle is alternating this angle. This angle is what? Alternating this angle. That's what you're going to notice. And if you look at this diagram very well, you discover that you can now actually find this angle. You can actually find this angle. You can actually now find this angle. Are we together? You can find what this angle will be. All right, so your first task, so I'll call that angle small letter A. Your first task will be to try to find this angle. And once you have this angle plus this angle plus this angle plus this angle plus this angle will give me what? 180 degrees. For some of us who may be a little worried about How is this all clicking out? No problem. I don't think I've uploaded that video yet, but I'm going to upload some videos that will help you understand this video very well. All right. So what we'll need to do now is this. We'll start by saying using notations as in diagram. I'm using notations as in diagram. Now, one of the good things about using notations as in diagram is that I don't need to write so much. And in maths, the diagram you have speaks volume more than having to write so much. So with this diagram we have, you discover that A plus 88 will be equal to 180 degrees. And what's the reason for that? It's called allied angles. Allied angles. Allied angles AB parallel to what? TP. This angle plus this angle is allied. The angles, they are called allied angles, or what is called co-interior angles. They are called allied angles or what? Co-interior angles. So this angle plus this angle will give us what? 180 degrees. So A will now be 180 minus 88 degrees. So what do? You do your relevant subtraction, and that will give you what? 92 degrees. Now, this is just the first phase of what we have done. You've gotten this angle now. So the next thing you need to focus on now is, we know that angle at a point is what? 300 and what? 60 degrees, all right? So we will say that A plus X plus 3X will be equal to what? 360 degrees. But in geometry, you don't just drop the thing in there. You need to tell us the reason. It is the reason that earns you the mark. So we'll say that angles at a point, right? So with that, what is A? A is 92 degrees. If we did our maths right, plus X plus 3X will give you what? 360 degrees. And 92 plus 4X will be equal to 360 degrees. Now, what I notice some students will do, they want to do what? Move this to the other side. No, if you look at this number very well, that's why you were taught rules of divisibility. You can actually divide through by 4, and that will give you 23 plus X equal to what? 90 degrees. So X is equal to 90 minus 23 degrees, and that should be something in the neighborhood of 67 degrees if we have done our subtraction and addition very well. Like I always advise, and when you're solving problems, try to excite every aspect of your brain. Use every aspect. Don't always follow a particular method. No, because that's what will help you to answer even more complex questions in the exam. All right, I'll give you some time to copy that out, and then I'll be back shortly. Okay, we go to question 5 now. Question 5. Now, in question 5, we are told that this is the diagram we are given. Something that looks like a W. This angle is 52 degrees. The whole of this angle is X. The whole of this angle is 312. This is A, this is B, this is C, this is D, and this is E. And we are told that this is parallel to this. So that's the virtual representation of the figure we are asked to solve. Right now, we are told in the figure to find X. In this diagram, BA is parallel to DE. Find the value of X. Essentially, it's another Y question. Find the value of what? X. All right. So, how would we solve this? Here again, I'll still use my former technique. I will create a parallel. I will watch it such that AB will be parallel to, let's call this, this is C. Let me call this EF, or sorry, PQ. So this new parallel line I've drawn is parallel to this and it's parallel to this. And I've called that line PQ. Right? What are the relevant deductions we can make from this? I'll call this angle, let me call this angle small letter Y, and I'll call this angle small letter Z. So what do you observe? You start by telling your examiner using notations as in diagram. This is my own style of writing. I always like to use notations as in diagram. So you start by telling your examiner using notations as in diagram. Maybe I should clean that and try to avoid my writing exceeding the boundary. So using notations as in diagram. Using notations as in diagram, you discover that Z will be equal to what? 52 degrees. Z will be equal to what? 52 degrees. What's the reason for that? Z and 52 are said to be alternate angles. Alternate angles, what? BA parallel to this new line I have drawn, PQ. All right. The next thing we'll do, we have gotten this is with Z now. I called here Y. Let me call here W. Let me call this other part W. So what you're going to have now is this. Now let's look at this Y, because Y will be equal to W. We cannot get W except we have gotten Y. So look at that. So it means that Y plus 312 degrees will be equal to 360 degrees. What's the reason for that? Angles at a point. The concept of angles at a point will give us Y equal to what? Y plus 312 equal to what? 360 degrees. So once you have that in place, you can now go ahead to say that what? Y will be equal to 360 degrees minus 312. And that will be equal to 48 degrees. That will be equal to what? 48 degrees, right? Now I've gotten Y. Now W will be equal to Y. What's the reason for that? Alternate angles, DE parallel, alternate angles DE parallel to what? PQ. DE parallel to PQ. Watch the angle, see W, see Y here, see W here. So those two angles are equal because the angles formed between parallel lines with the transversal cutting across. Now W will now be equal to what? 48 degrees. Now with that in place, we can now say that Z plus W plus X will be equal to 360 degrees. And what's the reason for that? Angles sum, angles at a point. Angles at a point is what? 360 degrees. What is Z? Z is 52 degrees. What is W? W is 48 degrees. Plus what? X. And that will be equal to 360 degrees. So add these two together. This will give me what? 100 degrees plus X equal to 360 degrees. So what do you have? X will be 360 minus 100. And that will give you 260 degrees. So the answer invariably is what? 260 degrees, assuming we have done our relevant calculations right. Okay? The next aspect we'll be considering is what is called triangles. In grade 8, which is your JSS2, I've been privileged to teach mathematics in grade 8 and also been privileged to treat or teach basic technology. And whether you're treating geometry in mathematics at grade 8 or you're treating what is called basic technology, that's geometrical construction, we've established that there are three key ideas that establish or make up any shape: the concept of a point, the concept of lines, and the concept of what? Angles. These are the three building blocks of any shape. Today presents us with the first shape in the series of shapes, and that shape is called a triangle, from the concept three. The word tri suggests three. So three angles, three angles. So when you hear three triangle, you're talking about what? Three angles. Okay, so essentially a triangle would look like this. A triangle is a polygon with three straight sides, and we would label it A, B, C. Now, in mathematics, when we started this topic on this concept of geometry, we had established that a point is represented with what? A capital letter. Because sometimes students find it very difficult to understand why this is a capital letter A. You can't use small letter. In fact, if you use small letter here, you're wrong. The only time we use small letter to represent an entity in math is when we're talking about what? The angle or the side. So if we're to rename this figure, take into consideration the sides and the angles, this will be what? Side A. This will be side B. This will be what? Side C, in small letters. So this side I've called B is actually called what? AB, in terms of capital letter or capital letters. Also, the angles at this point could be represented with capital letters where they are standalone points in a shape, or we could use small letters. Let me call here X, I can call here Y, I can call here what? Z. Small letters, small letters. So please take note of this. They may sound very just simple and just there, but you really need to know them, because these are the ideas that will help you understand the concept of maths or geometry as you progress. I tell my students one thing: understand the concepts. Understand the concept. Don't be in a hurry to just want to solve problems and run. No. Understand the concept. If you understand the concepts, even when you're very slow, you will catch up and overtake those who were ahead of you, because the concept helps you to think, helps you to see where the subject or the topic is going to. All right, so this is a triangle, and these are the sides, these are the angles, these are the sides, and then we'll take it up from there. All right, so with that said, we're going to look at the types of triangles. We're going to look at what? The types of triangles. And this is where I'm going to be doing a little adjustment to what I've been teaching over the years. Now, I tell students that there are 4 types of triangles, because in my classification, no matter how you look at triangles, you discover that there are 4 types. But I have a resource material, since it's my reference resource material, and knowing well that students would resort to it, I decided to do a tweaking on my classification of triangles so that it flows with what I have here. Now, according to the resource material I have here, triangles can be classified into using 2 major criteria, or criteria rather. You could classify triangles by looking at their sides, or you can classify triangles by looking at their angles. So I'm going to take that up now. So we'll start. We're going to look at types of triangles as a function of what? Angles, or let's say as a function of what? Sides. So if you're going to talk about the types of triangles by virtue of the sides, we're going to have 3 types. Number 1, number 2, and number 3. The first one is what is called your equilateral triangle, equilateral. I'm going to draw a diagram to show you what that looks like. The next type is what is called the isosceles. And the third type is what is called the scalene. So it's called the scalene triangle. Now, pictorially, it's important for you to be able to show pictorially what these shapes look like. Now, for an equilateral triangle, it is a triangle that has all the sides equal. All the sides of an equilateral triangle are equal, and by extension, all the angles are equal. Now, there's also another knowledge I want you to bring to bear here. In your grade 8, for those who were privileged to be taught by very sound basic tech teachers, you would have been told that the number of angles present in any shape is in direct proportion to the number of sides. So for a triangle, we have 3 sides, so it will have what? 3 angles. So if you use the word equi means equal sides, equal laterals or equal sides, it will mean that this figure will have all the angles as being what? Equal. Okay, so for isosceles, we have 2 sides that are what? Equal. For isosceles, we have 2 sides that are what? Equal. And for scalene, we have a situation where the sides, where no side or sides are equal. So they're all having different values. Having what? Different values. So this side is different from this side, is different from this side. And by direct implication, their angles will not be equal. For this isosceles, by direct implication, 2 of the angles will be equal. Now, let me shock you with something. The longest side will always face the biggest angle. Now look at this. This angle is the reason why this side is the longest. This angle will open to the extent of this side. This angle will open to the extent of this side. This angle will open to the extent of this side. Now, these are the things you need to take note of. They look like small ideas. You know, when you're watching this, I love the Marvel Cinematic Universe. When you're watching some of these movies, they are dropping ideas for you. You need to be very, very sensitive. And something I've enjoyed about them is that they really do their homework. See, it's more than just watching a movie. They really do their homework. I do a lot of reviews and watch a lot of reviews on these movies, and you discover that they do a lot of homework. They rarely make mistakes. So that's the same thing that happens in maths. Every detail, you need to, and if you're very inquisitive, very soon you start doing well in maths. You don't need to be intelligent to do well in maths. You just need to be inquisitive. Why is this thing like this? And as you keep seeing it, oh, this is why this is, you just discover that you're making improvements. Okay, so that's for the types of triangles, taking into consideration what? The sides. Now, before I go into looking at types of triangle, considering the angles, it's important to understand that for a triangle, we have special properties. A triangle must, number 1, have 3 sides. A triangle must what? Have 3 sides. Number 2, it must have 3 angles. Definitely, we said that the sides will correspond to the angles too. But another interesting thing about the triangle is that the sum of the interior angles is what? 180 degrees. The sum of the interior angles will be what? 180 degrees. That's an interesting thing about the triangle. The last, which I'm going to say for the last, and it applies to every shape, usually what a shape we call the polygon, is that the sum of the exterior angles is what? 360 degrees. Now that's something that applies to the polygon. We'll look at polygons sometime in the course. I've mentioned something, I've just dropped an Easter egg, polygon. So if I were you, I'll go back and do my research and try to find out what then is a polygon. All right. So we've looked at the types of triangles, taking into consideration their sides. Now let's look at types of triangle, taking into consideration their angles. Remember when we treated angles? We treated 6 types of angles. The first we treated was obtuse, angles that are less than 90 degrees. The second was your right angle, which is exactly 90 degrees. The third was obtuse, above 90 degrees, but less than what? 180 degrees. The fourth was a straight line. Students find it difficult to believe that a straight line is an angle. A straight line is an angle, and its value is 180 degrees. That should be is that the third now or the fourth? That's the fourth. The fifth is what is called the reflex angle. An angle reflex, and I said to reflex is to flex. Very funny. But that's an angle that is above 180 degrees, but essentially less than 360 degrees. And the final one is what is called the angle at a point. For me, I call it the angle I used to draw a circle. The angle drawing circle. Angle at the point is what the angle drawing word circle. Take it. It's official. It's me. You've not heard it anywhere before. All right. Okay. Just a joke. Now, we've done that. 6 types of angles. Remember, I've told you that the sum of the angles of a triangle is 180 degrees. So, by some way of thinking, we already know the types of triangles by virtue of the angles. I can't call a triangle angle at a point. I can't call a triangle reflex. I can't call a triangle what? A straight line. Because I'll need 3 entities to give me that triangle. So it's obvious that the types of triangles can only be 3. Number 1, acute. Number 2, right angle. And number 3, obtuse. Awesome. You know, maths is wonderful. It's there. But if you're patient to look at it, you discover that all these ideas are there. They're just there waiting for you. I know you've not seen it in any book. In fact, I'm just seeing it for the first time. So don't think maybe because I'm a guru. No, I'm seeing it and it's official. When I draw this on YouTube now, this will be the first and the most official talk when it comes to triangles, looking at it from this perspective. All right, so let's go. Number 1, we have what is called acute. We have what is called acute angled triangle. Number 2, there's what is called obtuse. Should we take obtuse angled triangle? And number 3, there's what is called the right angled triangle. Prior to now, in my concept development of this topic, what I do when I teach this is to treat this one rather, as a 4th type. But that's the beautiful thing about knowledge. That's the beautiful thing about upgrading. As you grow, you see things better, and then you change your paradigm in terms of passing the knowledge across to your students. All right, so this is now more like an official arrangement of triangles, and that will form the basis of the new direction I'll take when I teach this subject to any of my audience. Now, acute angle triangle means that what? It will mean that for an acute angle triangle, we expect to see all the angles as acute. I'll take that again. For an acute angle triangle, we expect to see all the angles as what? Acute. So if I have a triangle of this nature, I expect that all the angles, let me use small letter A, B, and C. So A, B, C are acute angles are what? Acute angles. So the three angles must be acute. Please, however you combine them, maybe we should put a bit of life to what we're talking about. Put a bit of life to what we're talking about. So let's assume I can have 60, 60, 60. These are acute angles now. So it means that an equilateral triangle is actually an acute angle. That's the implication, that an equilateral triangle is a special type, or is a type of what? Acute angle. Now, I can also have it to be something like 70, 50, and or let's say 70, 80, maybe 30. I see the combination. It will also still give me what? An acute angle triangle. Are we seeing that? So at the end of the day, what you have is also an acute angled triangle. All right, so let's copy that quickly. So let's continue. Now, that's for acute angle triangle. Now, what happens when we're talking about an obtuse or an obtuse angle triangle? In an obtuse angle triangle, we have one angle as obtuse. Remember, please, this is basic mathematics. Remember that for an angle, or rather for a triangle, we said that the sum of the two angles is 180. So if you have an obtuse angle in that triangle, it means you already have an angle that is above what? 90 degrees. If I remove, let's say, 100 degrees from 180, I'll be left with what? 40. So what are you seeing there? It means that for an obtuse angle triangle, we can only have one obtuse angle, and the remaining two angles must be what? Acute. So let that sink. In the case of acute angle, all the angles are all what? Acute, hence the name. But when it comes to obtuse angle triangle, one angle is what? Obtuse, and the others are what? Acute. So what do you observe? The angle opens out. So that's in drawing, your triangles will always look more like this. So B is obtuse, then A and C. So A, C are what? Acute. Are you seeing that? So that's for an obtuse angle triangle. B is what? Obtuse, and A and C will be what? Acute. Now, what happens in the case of a right angle triangle? One of the angles will be 90 degrees. So let's call that angle B, A, and C. So in this setup too, one of the angles will be acute, one of the angles will be, obtuse, and the remaining two angles will be what? Acute. Okay, so that will mean that B is right angled, and A, C are what? Acute. I'm taking pains to explain this because my research into mathematics for your contemporary time is that the reason you struggle with solving problems is because there is not enough understanding of these ideas. So you must eat these ideas. And that's why you see I'm spending such a long time. If you watch the way my classes are structured, the days I do talking on the subject, I don't solve problems, or I solve very limited problems. The reason is it's very strategic, so that when we solve problems, I call back what I have taught you to see how those things apply in problem solving. You must know these ideas. They must be very, very, very strong in your mind. It helps your decision making on what method to take while solving what problems. Okay, I'll give you some time to copy. Let's say about 5 minutes, and then I'll be back. All right. Now, the concept of hypotenuse in any type of angle-based triangle is tied to the biggest angle. Now, if you look at obtuse, it's obvious in obtuse that this B side, the side facing B, will be the hypotenuse. So when we talk of hypotenuse, let's not tie our mind to just right angle, because that's something I notice students do. When you say hypotenuse, their minds have been, our orientation have been tied to just right angle triangle. No, hypotenuse refers to the longest side of any triangle. So in this figure, this is the hypotenuse. And in this figure, this is the hypotenuse. So hear this and hear this. The concept of hypotenuse is tied to the largest angle of that triangle. Now let me even shock you. This figure you're having here, you can have an hypotenuse there or a hypotenuse there. Why? Because the angle, especially where all the angles are not equal, even amongst obtuse acute angles, there will always be one that may be bigger. So if that one is bigger, the tendency of it to open up larger than the others means that that side is a hypotenuse. So please, I want to disabuse our minds from the idea that hypotenuse only applies to right angle triangles. No, no, and no. So take note of that observation. What I try to do in my modern way of teaching mathematics is not to lock you up. I think some of the challenges we've had in previous math method is that you're locked up in a corner. So you don't have the strength or the grace to stretch or to check out other things. So what I'm trying to provide is an avenue for you to spread and check out other ideas. All right, so that's the little addition I wanted to make to this. And we're going to take one more idea and I think we should be done. All right, let's look at this diagram on the board. A, B, C, X, Y, Z. Now, looking at this diagram, when we draw a triangle in this manner, such that the sides are produced or extended, when you extend a side, now what I've done is to extend this side. This, okay, maybe I should change the narrative. Let's put it this way. All right. So what I've done is that I've extended the sides. So maybe I should name them again. I'll call it a P, Q, R, just to bring a bit of variety to what we're doing. Now, this triangle is called PQRO with extensions, maybe going to T, S, and then let's call this W, no problem, doesn't really matter. So what I've done now is that I have produced this to this, I have produced this, I produce this to this, I produce this out. Note what I've said, I've used the word produce. So note that because you're going to be hearing a lot of that soon. Now, these angles are what we regard as the interior angles of the triangle. So A, B, C are the interior angles of the triangle. A, B, C are the interior angles of the triangle. So what about X, Y, Z? X, Y, Z. These angles are called the exterior angles. Exterior angles of the triangle. So X, Y, Z are treated as what? Exterior angles of the triangle. Good. Now, if you look at this very well, these two angles are said to be adjacent angles. They're on a straight line. These two angles are said to be adjacent. Adjacent will connote lines side by side. So for every shape, if you draw it in this manner as I have on the board, the interior angle of one side directly relates to the exterior angles, exterior angle on that side, and it's actually 180 degrees. So what you have is this, this, and this. So each of these will sum up to 180 degrees from our previous topics, where we already established that the angles on a straight line is what? 180 degrees. Now, key to it is that the exterior angles x plus y plus z is equal to 360 degrees. And the reason for that is that what is what exterior angles, especially in maths, we just say exterior angles. So exterior angles of what? A triangle, or exterior angles of a polygon. I've mentioned polygon again. Now, polygon essentially are shapes that have straight sides. We'll look at that much later. And the first member of a polygon, group of polygons as it were, is the triangle. In fact, in defining a polygon, we said that a polygon is any plane figure that has, any plane closed figure that has at least 3 straight sides. So the triangle becomes the maiden member of these series. Okay, so the exterior angles of a polygon, narrowing the scenario to what we have here, a triangle, is actually what? 360 degrees. You should note this. You should be conversant with this figure. All right. Okay. Now, one other advice I want to give. Sometimes in your schools, you'll be asked to use new general mathematics. It's not bad. You should use the idea you gather from here to solve problems in your new general mathematics. All right. Okay, so that wraps it up for what we've learned today. In our next class, we'll be going into practical solutions to these problems. What we'll try to do is to build our knowledge and get familiar with the shapes and basic things we need to know. We're now going to the theorems. There are theorems that help us to handle some of these things. So in our next class, we'll go into theorems and we'll trust that we'll be able to build on that.